Good afternoon, everyone. Thanks for showing up in the last day after the lunch break. I really appreciate that. So I'm Bharat Tivula. I work at Verizon India, and presenting along with me Trinath Somanchi, who works at FI Networks. There's one more speaker, Dharmendra, who is Tacker PTL. He could not, unfortunately, show up today. Being worked on both ONAP and the Openstack Tacker, which is the homegrown NFEO and VNFM in Openstack, we find some of the Openstack solutions that can be used inside the ONAP. Though there are some of the components being natively grown in ONAP, but that can be easily used by the Openstack because all of the ONAP deployments are done on top of OpenStack. So that is the main soul of this presentation. So here's the agenda. So first, if anyone doesn't know about ONAP, we'll go with what is ONAP and the basics of ONAP components that is relevant to the discussion for today. And then we'll go about how Tacker can be added or integrated with ONAP as a VNF manager or as an NFEO. And then later, Trinath will explain about how the other OpenStack projects can be integrated with ONAP and then add value to the ONAP. And then he will discuss about how ONAP can be integrated with the Starling X, either as a multi-cloud plugin or as a deployment solution. A disclaimer before starting, if I am biased to any project or have any opinion on any project, it is purely mine. So that's a disclaimer. So what is ONAP? So ONAP started by the Linux Foundation in March 2017. It was a merge of both OpenEComp and OpenO. So basically, ONAP is a platform that provides the real-time and policy-driven orchestration. It automates the physical and network function so that it helps network providers to quickly launch their network services. So basically, it is a suite of multiple components, not just NFEO. If we go to the ONAP community, there are two types of platforms. One is called design time, the other one is a runtime platform. So if you see the left-hand corner, the blue box is called design time component, and the right-hand corner is the components on the right hand is mostly about runtime. So the design time component constitute, or the main functionality of the design time is to design your network functions or virtual software products or your network functions. And the main components of the design time components in ONAP is the SDC, Service Design and Creation, and the CLAMP, which is the Closed Loop Automation Management Platform. So it helps to design your policies and push to the runtime component so that after the deployment of your the network functions, it can able to make the operator to see the monitoring of the metrics or to scale out or scale in the network functions. So what are the models you designed in the design time and the policies you designed through CLAMP that all push to the runtime? So in the runtime platform, it takes the models, either it can be a heat template or a Tosca or a rules policy. It takes that input and try to instantiate the network function. So all these NFEO, the inventory, the message, DMAP, all this constitute the runtime platform. So if you come from the NFEO background, you don't see much value from the design time or runtime division, but I can divide the main subsystem of ONAP as NFEO or a VNFM and the service assurance subsystem. And there is one more layer which supports all these three blocks, which is supporting tools like the inventory or the proxy called MSB, all other components. So let's go with these blocks. So I won't cover all the components because those are not relevant to the discussion, but I will cover those components which is relevant and then which can be leveraged by the OpenStack projects. So in ONAP, there are two NFEO orchestrators. One is called Service Orchestrator, which joined the project from the OpenEComp. So when a service design is created through SDC, it is pushed to the multiple components. One of the component receives is the Service Orchestrator. So this Service Orchestrator is not based on the ETSMO, it came its own design model. So it is completely based on the BPMN. Internally it has a Camunda BPMN engine. So all the flows to create the network service is fueled basically through the BPMN flows. There is one more the orchestrator I told about, which is called virtual function controller. So all the VNFs, it came from the OpenO project. So it completely pure play Mano NFEO. So currently it supports multiple VNF manager, either grouped as specific VNF manager and the generic VNF manager. So currently till Casablanca release, it supports Huawei's, Jetty's and Nokia's specific VNF manager, and the generic manager will talk to the Openstack through multi-cloud project. And this is the biggest component or biggest subsystem of the ONAP, which is the service assurance. So after launching or after deploying your network function, I want to monitor as an operator, I want to monitor or see its availability, see the metrics. So in that case, I need the service assurance component. So there are three major components which involved in the service assurance. One is the DCE, data collection, analytics and platform. The other one is the policy. So you push the policies and through DMAP it will come to the policy component. And through VS, so whatever the VNF you deployed, it has to contain the VS agent. VS is the virtual event stream that is started as a project in the OPNFE. So in the ONAP, the VS agent in the network function sends the telemetry data to all your service assurance subsystems. So the VS agent sends the data to the VS collector, and the DCI component is take the metrics and then try to find the threshold values based on the policies you deployed in the design time. So once you find the threshold crossing analysis, after the threshold crossing, you send an alarm to the policy, and the policy will try to trigger a corresponding action either to SO or by itself. Like I want to scale out a new network function, I will do that through SO. So this is the ONAP basics, but how can I leverage OpenStack projects into the ONAP? Can I add Tacker to integrate Tacker to the ONAP? Tacker, as I said, it's a OpenStack homegrown NFEO and VNFM. Let's take the Tacker as a VNFM role for now, and then can we integrate with ONAP? So for that, I have to tell a couple of standards that we must know. One is called as Sol3 interface, and second is the Sol5 interface. So these are the API standards that are proposed by the ETSI. So Sol3 interface is between your NFEO and your VNFM. So if any of your VNF manager supports the Sol3 APIs, then it can easily integrate it with ONAP. But at this release, in the current release of OpenStack, Tacker doesn't support the Sol3 APIs, but using a plugin which takes the calls from the VFC and converts to a Sol3 to the Tacker, so can be added, and then so that you can integrate Tacker with your ONAP. So okay, I have added the Tacker, but what is the benefit I can get? So previously I said that you have to design policy separately, and you have to define your topology separately, and then the policy also contains multiple languages. Like you can have the rules engine, you can have the Apex engine, or the other new future engine can support different languages. So you have to write you have to solve each and every problem in a different language. Whereas if you take Tacker understands the policies all in one language. I can define my topology, I can define my policy, I can define my forwarding graphs. I will discuss that in the next slide, all in one unified language called Tosca. So if you design your network service and your policies all in one language, and then push it to the Tacker will handle all those things through its own Tosca base. The other benefit is, except the inventory, I can take all the service assurance components from the OpenStack instead of using the ONAP service assurance. It may not work for all the use cases, but if based on your use case, you can have a trade-off between, can I use ONAP service subsystem or the Tacker's or OpenStack subsystem. So what is the difference between the service assurance if I take from the Tacker or from the ONAP? So as I mentioned before, there's one unified language through Tacker, or you have to do with multiple and then decide which is the right language for me in policy in ONAP. And the second one is I don't have to install multiple service assurance subsystem if I use OpenStack Tacker. It completely uses other OpenStack services to monitor my VM or to get the data from the VM. Whereas if you use ONAP, you have to, based on your network function type, you have to either use a VS agent or your SNMP mapper. So based on the use case, you have to define your own metrics collection. And the one limitation if you use Tacker is it cannot take your application data as it is. It can take your VM metrics, but it cannot take the application specific metrics. But in the latest release, Tacker also adds a JABX based metrics collection, but it may not work for all network function. But if you go to ONAP, you can get through VS agent, you can get from application level, like how much traffic I get through the firewall, how much. So all the application level metrics also I can get. Okay, I added Tacker as a VNFM, but can I add Tacker as a NFEO? Yes. So I told about Sol3 and Sol5 interfaces. So Sol5, the interface is between your OSS-based system and the NFEO. So if your NFEO supports the Sol5, then you can integrate your NFEO to the ONAP. So in the latest release, in the Dublin release of ONAP, the ONAP supports Sol5 APIs from Service Orchestrator to any other external NFEO. So if I integrate Tacker as NFEO, I can get the service function chaining out of the box, which is not available in the current release of ONAP. So if you integrate Tacker, you can get out of the box because Neutron have the Neutron SFC that helps to create your service function chaining. So this is the integration of ONAP and Tacker, but now Trina will explain how other projects can be leveraged and then add value to the ONAP.
Thank you, Bharat. Since we have discussed about the fundamental building blocks of what ONAP is and how the VFC and service orchestration, service assurance functionalities from Bharat, we'll move forward with what we know in ONAP, OpenStack today, and how can we extend the existing functionality, what we have in OpenStack landscape to ONAP. And this is one of the great pictures where everyone in OpenStack community know this, because this provides a complete overview of what are the OpenStack projects that are being built and famous in OpenStack ecosystem. And where they are here, the projects are also classified into what they are going to solve. So if you see, we have the compute resource with Nova, Zun, and cynllun. And we have networking with Neutron and Octavia and Designate. We have bare metal with Ironic and Cyborg, and storage with Manila, Cinder, and Swift. So these are some of the projects that OpenStack today supports with the different as-a-service initiatives solving different challenges. So I cannot take all these projects for this presentation regarding how they solve how can they themselves make a good sense in being used in ONAP, or how can they complement the things that their positioning in ONAP will really help in realizing the use cases. I have taken forward few projects which will really make sense in the thing that is the Tacker, which Bharat has covered. And when we talk about this NFV, we always talk about ETSI, NFV end-to-end architecture. So since Tacker is aligned to that, and OpenStack is very much positioned in that architecture design as virtual infrastructure manager. And it is one of the open source community solving public, private, hybrid, and multi and telco cloud challenges. And OpenStack is the default Vim solution, that is the virtual infrastructure manager solution that we see today in most of the open source communities that are working on NFV platforms. Where in Kubernetes has taken the place, and OpenStack are best complementing friends while designing with containers and VMs in the NFV ecosystem. So let me start with Neutron. So Neutron is the thing as virtual networking as a service. So in Neutron, There are many projects, sub-projects called networking as a service projects, where we have networking service function chaining, where previously Bharat has outlined the service function chaining what Tacker provides. So the Tacker uses networking SFC project from Neutron, its collaborate approach, and it uses the cynllun clustering framework from OpenStack. So Tacker is a project which is the NFEO framework in OpenStack, which collaborate with different projects. And with Neutron, we are stitching this cloud fabric because we have a programmable edge to the cloud networking fabric. We have integration with different software-defined networking controller solutions into our virtual networking fabric, where we can really ease the things of defining and realizing our use cases like VCP, VULTE, and VEPC. And we have a software defined fabric for different ONAP use cases, where it is container networking. We have the courier integration for containers. And this way, moving forward, there are much more challenges that Neutron can solve. Because if you consider the releases of ONAP that happened, so there are 3 releases currently available: Amsterdam, Beijing, and Casablanca. And if you see the Amsterdam, there are certain use cases that are realized: residential VCPE, VVOLTE, vFirewall. And Beijing, they laid the foundations for 5G. And in Casablanca, they have moved to support things that are related for 5G. And moving forward for the future releases like Dublin, they are going to move more towards realizing more use cases that are more towards the service provider space. And moving forward, ONAP will also, I think ONAP will also move much more forward towards the edge, supporting V2X kind of communication scenarios from the data center to the what I can say is the edge scenarios. So in that sense, we have this 5G, since ONAP with the Casablanca release has made a very good foundation stone for 5G. And moving forward, it is going to have much more 5G use cases. And what good thing is AT&T and Ericsson demo with 5G virtual reality in our keynote on the day 1 of this summit, that proves that we are really consuming 5G in a very more faster way. How can this ONAP, this Neutron help for ONAP? Because as things internally, when we see, we are all stitching the fabric. It is something like steering the traffic across the VNFs and physical network functions, with aligning towards the use cases or the challenges we are going to solve in this space. We have the networking SFC, BGP VPN, and OVN solutions. And Neutron provides QoS functionality, and group-based policing is much more related to service chaining, something like ordered chain of services by separating out the network policies for service-specific details. And we have Octavia as a fundamental project which provides the operator-grade load balancing as a service. And road-based RBAC is something like sharing your network across it between the tenants, and common classification framework, which classify the as-a-service kind of stuff which you are using in realizing NFEO use cases. So this is not a limited list of support what Neutron can provide today with respect to the other use cases what ONAP is going to realize in further releases. And there is much more stuff because we have limited the things which are much more realistic that can be much more nearer to the use cases that it is solving today. And moving over, there is cynllun. Cynllun is a clustering management as a service where Tacker deeply uses it because we have the instantiation, start and stop the lifecycle management, scale in and scale out. And because the cynllun engine supports different policies and support OpenStack SDK, which supports the virtual machines and heat stacks. And cynllun engine also supports a Docker, which supports the containers. And here it is how we can integrate this cynllun, how can it help in ONAP? Since it is a cluster management service in OpenStack, it can support heat resources. Here is the heat template where we borrowed from OpenStack cynllun documentation, which proposes the cynllun resources. So the service orchestrator can create cynllun resources while deploying the VF modules. Using the monitoring solutions, we can expand, that is the scaling and shrink the cluster resources and provide a closed loop functionality. The closed loop functionality is something like a goal where ONAP is working towards. And there is another project called OAth. As if you see, Bharat has discussed about VS agent that exists in the VNF, and the VS collector who does the align itself to DCAE and does the policing and telemetry kind of service, where we can make use of cynllun for the collection of metrics from OpenStack, from the VNF, similar to the role of VS collector, what it is doing in ONAP. We have Nuchi, which can store the time series fashion of metrics. And we have OAth, which can trigger the alarms based on the policy or based on the happenings in the cloud. So this way, we can use 3 kind of projects. And here I want to say, though cynllun is currently not in support today, but we can still use the code base and we can upgrade it as per the requirement to realize the use case what we have. And the other good thing what we have in OpenStack is Zun, the container as a service, where this container is a kind of OpenStack resource now today with Zun in place. And because Zun is an OpenStack project, it easily integrates with the OpenStack projects which support authentication, image storage, and other things, networking with Neutron and Courier. And users can create and manage containers to APIs. And they don't see any difference what is the underlying container technology while they use the Zun. So this real capability can enhance the containerized VNF deployments in ONAP. And Zun has been integrated with multiple OpenStack services like Keystone, Neutron, and Courier libnetwork. And what are the advantages do I get if I integrate Zun in ONAP, where user can extend the functions of container and the complete OpenStack ecosystem to help in a very stabilized manner for your ONAP use cases. And for orchestration, we have Kubernetes and heat resources for Zun. And Zun has a specific kind of implementation like capsules, which relate to pods in Kubernetes. So this kind of aggregation will really help ease the use case implementation in ONAP. And finally, we talked about how to how can OpenStack really help, the OpenStack projects really help in ONAP achieve its use cases and goals. But moving forward, in the initial releases of ONAP, many of you who had tried ONAP when Amsterdam release in place, you have ONAP Operations Manager, which will install many VMs, many containers, with all this DCAE stuff and other VFC and other kind of stuff there. So in this kind of things where we have StarlingX today, distributed edge deployment solution, which is grooming out from open infrastructure space, where since ONAP is a huge deployment, and ONAP edge use cases can use StarlingX from the deployment stage of ONAP, and StarlingX is OpenStack and Kubernetes-based deployments are possible, and ONAP in K8 cluster deployment by OpenStack using StarlingX is possible. Since this is a fully featured cloud which can deploy OpenStack for ONAP, this project also takes into consideration of complete OpenStack ecosystem that can help ONAP to bring up the key requirements of configuration, FCAPs, and other performance and low latency requirements. And the code is already pushed to multi-beam project of ONAP. And this is how the OpenStack landscape, this is not a limited thing. There are other projects which can really make a very good footprint in ONAP, realizing the use cases in the service provider tier. And this is where we thought of having and bringing the benefits what we get from OpenStack today into the open ONAP space. And
so the main motive of this presentation is to suggest or recommend what already available in OpenStack and use it in the ONAP, not the other way around. So you have a big multiple subsystems, and then if your use case doesn't need that, then use your OpenStack, because all your ONAP workloads are on top of your OpenStack. So thank you very much for attending this session.
Thank you all. And we are open for your questions or some discussion if you have.
Just a quick, the Taka integration into OwnApp makes perfect sense. I think I get that. What I'm struggling with is the Neutron part and what you're trying to achieve there. Because today, you create your resources from OwnApp, you're still using Neutron one way or the other, be it over OVS or whatever network system you are using. What I'm not getting is, what are you pitching here specifically for Neutron integration into OwnApp?
So, some of the projects you cannot directly use through OwnApp, but through Tacker. Let's say, for example, in the Neutron case, I want to use an SFC part.
Okay.
I can do through Tacker because I cannot have the networks like forwarding graphs inside the heat template, but that can be done through Tacker.
Taka, yeah.
So
that's why I'm saying the Taka integration, it makes perfect sense. Right. I get that. But what I'm struggling with is the Neutron part.
Yeah. So whatever we suggest, it can either directly you can use, or some, like what you pointed out, it can be used indirectly through Tacker or some other project.
Got it. Okay.
Yeah.
I can add to that answer too. I'm on SDNC, SDNR, OM, and various other projects.
Yeah,
Yes.
So to help add to the answer, effectively through all the different plugins that we do, that we have available through the SDNC, with some of the other things going on upstream in Open Daylight, you could theoretically also make use of Neutron in that schema as well. So you could effectively have a netconf controlled switch over here, something provisioned, indirectly via OVS, via Neutron over here, stitch these things together through an entire service logic chain. So
That's right.
yeah.
Right.
Just think of it more plugins, more extensibility. So Neutron does have a place here, definitely.
yes.
That's right. And the SDNC project, in the current release, there is no creation of forwarding graphs through SDNC. So that is, if in future release, if it support, then use it, or otherwise through other project we can use as SFC. So SDNC is the main component to do the SFC part.
Yeah.
So any other questions you have?
So I have a question about, how much, I know you're working with the ONAP community, but how much has this resonated with on the ONAP side?
So from the ONAP community, it is my opinion. So from the ONAP community, if there is any problem, they are trying to have a new component or new solution, but so they're not using the OpenStack, all the components or services as it is. So that is the main motive for my presentation, to just suggest there is the problem is already solved in OpenStack, just use it in the OwnApp ecosystem.
It is something like whenever a new use case arises, new challenge arises, so they want to write something new. But reinventing a wheel doesn't make any sense, because OpenStack is not such a simple thing where it is a stadium of very good number of projects providing as a service implementations. So it is not just we can just pick out that block and put it here and that will work. It is something like we may need to modify certain APIs to suit the requirements of OwnApp, so that that block fits into that and realizes that use case. So the main motivation of this presentation is something like, how can we leverage the existing stuff, the beautiful stuff we have in this OpenStack stadium of projects that can really do the very good thing complementing the OwnApp use cases, so that both open source communities really can collaborate to realize the real use cases.
So that's a follow-on question. Have you thought about pieces of OpenStack that might need to change and need to be driven back into projects to support OwnApp and vice versa?
We have.
I can tie both those together.
Okay. Yeah.
The answer to the previous item is volunteer people to work the use cases, to submit the use cases, and most, as everyone here knows, most of the OpenStack stuff is ready, it's turnkey.
Yeah.
Could
Yeah.
be consumed. Those of us that are deploying ONAP via OpenStack are not necessarily using ONAP to then consume and deliver OpenStack. But I believe it's ready enough, but the answer is the same throughout. Volunteer people to work the use cases in the upstream.
No, I wasn't assuming you would use ONAP to deploy OpenStack. That's not really.
I'm saying
No.
not to deploy OpenStack, to deploy your use cases using the features that are available.
Yes.
Yeah.
I need to say that clearly. But it comes down to volunteering the people for the ONAP teams. People are happy to work on the additional use cases. There's so many we can fit in every single release cycle. Just volunteer somebody to work that use case, to deliver.
Perfectly answers this question.
Yeah, just makes
I was
sense.
just thinking like the Edge working group has found, there's some things that we need to change in some of the projects to support the Edge use case.
No, for the edge use case, you can use Starling X. I'm just saying you can use Starling X as an edge node and then orchestrate it through the ONAP. So we cannot change whatever the requirements we have from the ONAP cannot be pushed to the OpenStack. It is the other way around.
I would also, got my own opinion here. You can absolutely support edge use cases with OpenStack without Starling X as well.
That's right.
Yes.
That's right.
I don't want to draw that
Yeah.
Absolutely.
off-the-shelf OpenStack is already being used to support edge use cases.
Yes.
That's fine.
True.
That's right.
Nothing against Starling X, it's a great project. I'm just saying that it's already being consumed by ONAP deployers. It's just, there's not anyone volunteered to really laser focus in on
I
making
guess
that
that's where I was
document.
saying,
Yeah.
maybe there needs to be some focus on,
Yeah,
you may bump into a rock,
Yeah.
sure.
not a wall, but a rock.
And it really comes down to, more people volunteering to just get the work done, and get the edge group and ONAP, the edge group here to play.
Yeah.
Or
That,
We do talk to each other.
yeah, we need to talk.
that's the difficult part. Yeah.
Okay. Thank you,
Yeah,
guys.
thanks a
Thank
lot.
you all. Thank you very much.